So this is an example of a back titration, and the reason we do a back titration in this case is because calcium carbonate doesn't dissolve well in water. So in this case we're adding a known amount of excess acid. Some of the acid is neutralized by the calcium carbonate. We titrate what's left, and the difference is going to be the amount that was neutralized. So when we add the hydrochloric acid initially to the calcium carbonate, it's going to react in a 2-to-1 ratio. So we get 2 moles of hydrochloric acid to every 1 mole of calcium carbonate, and we make calcium chloride, actually carbonic acid, although that's going to break down to water and carbon dioxide. So we need to know how much acid we added initially. So the amount added initially of hydrochloric acid, that we know because we know that we have 10 milliliters. Let's convert that into liters. So we'll do 0.0100 liters. Multiply that by the concentration, which was 0.5, and that'll tell us how many moles. In this case, it's going to be 5 times 10 to the minus 3. Okay, and we'll come back to that later. We'll subtract the amount that was actually left over. So let's calculate how many moles were in excess, or how many moles were left over after some was neutralized. And we do that by performing a titration with 0.1 molar sodium hydroxide. So this is going to be a 1-to-1 ratio titration. So HCl plus sodium hydroxide will give us sodium chloride plus water. Okay. So figure out how many moles of sodium hydroxide we use to get to the end point. So it's 0.1 molar times 33.32. Need a point there. Liters. So that's going to give us 3.33. We'll just keep the 3 sig figs. Well, we could put 4, but 3 is fine. Times 10 to the minus 3 moles of sodium hydroxide, and because that's a 1-to-1 ratio, we know that's also equal to moles of HCl. Okay. Now we want to know how many moles of HCl were neutralized by the calcium carbonate, so we're going to subtract. So we had 5 times 10 to the minus 3 moles that we initially added. We know that 3.33 times 10 to the minus 3 moles were left after some of the calcium carbonate had neutralized. So we end up with 1.67 times 10 to the minus 3 moles of HCl. Now remember that reacted in a 1-to-2 ratio with calcium carbonate. So 2 moles of HCl with 1 calcium carbonate, so we're going to have to divide that by 2. So that gives us 8.34 times 10 to the minus 4 moles of calcium carbonate. So we know how many moles of calcium carbonate were in the original sample. Now we just need to get that into mass, so we can get a mass percent. So 8.34 times 10 to the minus 4 moles. The molecular weight of calcium carbonate is pretty much exactly 100 grams per mole. So we end up with 0.0834 grams of calcium carbonate. And to get a mass percent, we just divide that by the mass of the sample. 4 grams. The mass of the sample was 0.5 grams. Multiply that by 100 to get a percent. And we end up with 16.68%.